me? Give me. Okay. So before. So this is HCl, correct? So we have studied in our first term that HCl is made up of hydrogen and chlorine atom. So that means both are non-metals. So the bond is a covalent bond, which is formed by mutual sharing of electrons, right? So mutual sharing is covalent bond. Now in HCl, we have lab preparation. Now what is lab preparation? Whenever in exams, they ask you lab preparation of a gas. They can say lab preparation of an acidic gas or lab preparation of hydrogen chloride gas. There are 7 things that you have to remember in a lab preparation. Number 1, reactants. They will ask you, name the reactants. Now, when name is asked, you have to specify. You cannot write NaCl, you have to write sodium chloride. And what is the second one? Concentrated sulfuric acid. So when we speak about the lab preparation, reactants are sodium chloride and concentrated sulfuric acid. Now, why do we use concentrated sulfuric acid to make HCl? What is the property of this concentrated sulfuric acid? It is used as, by anyone can suggest? Tell me, why is
It's a non-volatile acid.
It's a very strong oxidizing agent.
No, not oxidizing agent. Here, what is the property? Non-volatile. Someone said non-volatile. Absolutely correct.
But why are we using concentrated H2SO4? Concentrated.
Yes, because in concentrated state, only it acts as a non-volatile. What is the meaning of non-volatile now? It means high boiling point, which does not get vaporized quickly. Okay. So sulfuric acid has boiling point of 338 degrees centigrade. So it does not get evaporate easily. That is why it is used to prepare highly volatile acids like HCl and HNO3. Now HCl is itself, it's a highly volatile acid. So if we use HNO3 over here, what will happen? Nitric acid vapors will volatilize along with HCl vapors. So you won't be able to collect HCl gas. So that's the reason we use concentrated sulfuric acid. Sodium chloride is used. Why can't we use other chlorides? Why do we use sodium chloride? Because it is more economical. Okay. Now, instead of NaCl, we can use KCl also. Conditions are very, very important in any lab preparation. Now here, the condition is less than 200 degrees centigrade. Why do we use the temperature less than 200? Why can't we use greater than 200? Can anyone tell me? Anybody?
And then apparatus, the glass apparatus broke.
Not necessary. That is for nitric acid. We may say it may crack. But what is the first reason?
And sodium,
yes.
And sodium sulfate is formed.
Yes. So temperature has to be kept below 200 degrees centigrade, because if we increase the temperature, then a thick crust of sodium sulfate is formed, which is difficult to remove, which can hamper the evolution of HCl. So that's the reason we always keep. And secondly, when we can make something in keeping the temperature less than 200, why should we increase this? The fuel is wasted. Okay. So this is the equation. Now, 2 things you have to keep in mind when you're writing any lab preparation. You have to mention conditions. Name is asked, sodium chloride and concentrated sulfuric acid. Equation is asked, concentrated word is mandatory. You have to write concentrated below H2SO4. You have to mention less than 200 degrees centigrade. And what are you making? You make sodium bisulfate and hydrogen chloride gas. This is not hydrochloric acid. This is HCl gas that we are making in the laboratory. Now, whenever we prepare any gas, we have to collect this gas. Now, how do we collect the gas? It is, whenever a gas is collected, either it is collected over air or it is collected over water. Now, HCl gas is collected by, it's written, you can read it also, upward displacement of air. Why do we say upward displacement? Why is it collected by upward displacement of air? Because it
Because
is
air is lighter than HCl gas.
absolutely. So anything which is heavy is going to go down, correct? So say this is my jar, it's a gas jar. If HCl gas is heavy, now empty jar contains air. Anything which is heavy is going to go down. So what happens, HCl being heavier than air, it goes down and air is displaced, okay? So air goes out. So that is why we say upward displacement of air or downward delivery. That's also correct, downward delivery. Now, why can't we collect it over water? Reason is because it is highly soluble in water. Any gas which is highly soluble in water cannot be collected over water. So that's the reason. Next, whenever we are making a gas, we need to know the drying agent. What is the drying agent used? Now, two questions can be asked to you in this. They can ask you, name the drying agent used in the lab preparation, which is concentrated sulfuric acid, or they may say, name the drying agent not used in the lab preparation. So the drying agent which is not used in the lab preparation will be calcium oxide. Okay, why? Because it may react with HCl gas, being basic in nature. HCl is acidic, calcium oxide being basic, it may react. Now, what are the precautions? This we've already discussed. Now, temperature we have discussed. The second precaution is that the thistle funnel, if you clearly notice the diagram of lab preparation, you will see in the round bottom flask, we have NaCl, and through the thistle funnel, we are adding concentrated sulfuric acid. Now, this thistle funnel should be dipped in concentrated sulfuric acid. Reason is to prevent the HCl gas from escaping through the thistle funnel. Because see, if the thistle funnel is not dipped into the acid, the gas may escape through the thistle funnel. So that reason is very, very important. They may ask you, whenever they ask you the precaution, you have to mention the reason. You cannot write precaution straight away. You can't write that the lower end of the thistle funnel should be dipped into the acid. You have to mention why. So to prevent the gas from escaping through the thistle funnel, okay? And temperature has to be maintained below 200, because if we increase the temperature, a thick crust of sodium sulfate is formed which sticks to the glass and difficult to remove. Now, if we have greater than, if we keep the temperature more than, they can ask you this equation. Write the balanced chemical equation when concentrated sulfuric acid reacts with sodium chloride at the temperature above 200. So you must know what is formed when temperature is above 200. Then you get Na2SO4 plus HCl. Always balance the equation. Unbalanced equations do not exist in chemistry. So whichever equation you are writing, make sure you balance each and every equation. But whenever they ask you lab preparation, you have to be sure about this. That temperature has to be kept less than 200 and NaHSO4 and HCl is formed. Now, there are a few things that we have to keep in mind. Number one, we say HCl gas fumes in moisture. Why? Why does it fume in moisture? If they ask you, give reasons. HCl gas fumes in moisture. What will be the reason for this? Can someone tell me?
It is highly soluble in water and therefore it forms a mist of droplets.
Very, very good. So that's your keyword. Being highly soluble in water, it reacts with the moisture present in the atmosphere. So it is reacting with the moisture, forming hydrochloric acid. Okay. So that has to be you have to complete the sentence. HCl gas being highly soluble in water reacts with the moisture or the water vapor present in the atmosphere, forming misty droplets of hydrochloric acid. So that should be your answer. Now, another thing, nitric acid cannot be used in the lab preparation because it is highly volatile in nature and it may volatilize along with HCl gas. Then third give reason may be, they may also ask you that HCl gas is not collected over water because it is highly soluble in water. Okay, so these are the few give reasons in lab preparation. Identification. Always whenever they ask you any preparation, they will ask you the confirmatory test, that how will you, once the gas is prepared in the laboratory, how will you test that the gas that you have prepared is the HCl gas or any gas for that reason. Here we are making HCl gas. How will we test the gas? It's a glass rod test. So it's very important that you mention each and every, there are keywords which are important here. So we say a glass rod, say this is a glass rod dipped in ammonium hydroxide solution. When brought near the mouth of the test tube containing HCl gas, dense white fumes of NH4Cl are seen. So the keywords will be dipping in ammonium hydroxide, bringing it near the mouth of the test tube or the mouth of the jar containing HCl gas, dense white fumes of NH4Cl are seen. And here, whenever they ask you aqueous ammonia, that means ammonium hydroxide, you cannot say a glass rod dipped in ammonia. It has to be ammonia solution. You cannot dip something in a gas. It has to be a liquid. Okay, it's very common. Generally, you know, when you're writing any answer in a hurry or whatever, overconfidence, you just write a glass rod dipped in ammonia. That's wrong. A glass rod dipped in ammonium hydroxide solution, when brought near the mouth, will give you dense white fumes. Next will be the experiment. Now, how do you, we said that it is highly soluble in water. So high solubility, how will you, which experiment will demonstrate the high solubility of HCl gas? Name the experiment.
A fountain experiment.
Absolutely, fountain experiment. Now, what is fountain experiment? Now, what happens? We take inverted round bottom flask. Okay, inverted round bottom flask is taken. We make 2 holes in the inverted round bottom flask. Through one hole, we insert a long jet tube. One end of the jet tube is inside the trough, which contains blue litmus solution. And from the other hole, we insert a dropper, which contains water. Okay. So one end of the jet tube is in the trough, which contains blue litmus solution. The other end of the jet tube is inside the round bottom flask. And this inverted round bottom flask contains HCl gas. Okay. Now, what do? We will press the dropper. The moment we press this dropper, water goes inside the inverted round bottom flask, which contains HCl gas, right? Now,
Yes, ma'am.
Correct. So what will happen? It quickly dissolves. HCl is highly soluble in water. So the moment water goes inside, it gets converted to hydrochloric acid. Now, the moment gas changes to liquid, what will happen to the pressure inside? It is lesser. Outside pressure is more. It will take the blue litmus solution, the jet tube will take the blue litmus solution up with a greater force. So what will happen? You will see a red colored fountain inside the round bottom flask. Now, if they ask you, name 2 properties. What are the 2 properties demonstrated in fountain experiment? Number 1 has to be, yes?
Some highly solubility.
Water.
Correct. Number 1 has to be high solubility. And number 2 will be?
Acidic property.
Acidic nature.
Very good, acidic property, because blue is changing. Now they can ask you in this trough, they may give you methyl orange solution. So what will be the change? Methyl orange will turn to?
Pink.
Pink.
Very good. It turns to pink. And if we have, generally they will not ask you phenolphthalein because it remains colorless. Right? In acids. Yes, that's the indicator test for acids. Now, next is when we talk about HCl being heavier than air. So how do we prove the experiment? There's a normal experiment. We take a gas jar, okay? A jar is taken. We just place a lighted candle in it. And then we take a jar which contains HCl gas. And if you pour HCl gas in this jar, which contains a lighted candle, you will see, because HCl is heavier, it will take the place of the air and the air is displaced out. So what will happen? HCl being, it's a non-supporter of combustion and it doesn't burn also. It's neither combustible nor it supports combustion. So we will say we will see whenever the air, whatever air is present inside, when it is, exhausted, so you will see the candle or the flame extinguishes. So this proves that HCl gas is neither combustible, nor it supports burning, nor it supports combustion. Okay. So these are the two experiments that you need to know. Now, when we say HCl gas, when we are talking about hydrogen chloride gas, so my question to you is, hydrogen chloride gas does not turn blue litmus to red. Can you give me the reason for this? HCl gas does not turn blue litmus to red. So what do we say? Why does it, why is there no change in the litmus?
Because the hydrogen chloride gas in gaseous state, gaseous state, it does not show the acidic property.
So no, it does not show.
Why? The presence of hydronium ions are not there.
Absolutely. Absence of hydronium ions. So that is the key word. So if I ask you, HCl gas does not turn blue litmus to red, you will say due to the absence of hydronium ions. Okay? Because, so when we are talking about, see, let's say for example, I'll just show you something. Say, this is HCl. So when water is on ionization, it produces hydronium ion, right?
Yes.
So hydronium ions are produced when water is added to it. Always remember, acids are the compounds which, when dissolved in water, produce hydronium ions as the only positively charged ions, right? So due to the presence of hydronium ions, it is changing blue litmus to red. Now, I'll change the question. If I ask you, HCl gas does not conduct electricity, give reason. It does not conduct electricity. Then what will you say? If I say HCl gas does not conduct electricity.
Because it does not contain mobile ions.
Very good. Because due to the absence of free ions or mobile ions. Okay. So this is very, very important. When we say something is not conducting electricity due to the absence of free ions. Something is hydrochloric acid conducts electricity due to the presence of free ions. Okay. Hydrochloric acid turns blue litmus to red due to the presence of hydronium ions. It's very simple. One-line answers. No need to write the paragraphs and paragraphs. Science is only about to the point. Just write what they're asking you, and that's it.
Ma'am, I have a question.
Yes.
In the fountain experiment, the jet comes, it turns red in color. There the litmus reacts with the, what does the litmus react with to become red in color?
Litmus combines with the acid, no? So
The
that's the indicator. Indicator. So whenever any acid, okay, whenever litmus is added to any acid, it will change to red.
No, I'm asking that it doesn't react with the HCl gas. It reacts with the HCl solution which is formed.
Of course, because of the presence of hydronium ions. Okay, due to the hydronium ions, this is what I showed you here. Because of the presence of hydronium ions, it is changing blue litmus to red. Okay, so that's the reason, right?
Yes.
Yes. Now let's go to the next one. Most important property, the typical acid. When we say hydrochloric, now we are coming to hydrochloric acid. Now, how do we convert? First, let's convert HCl gas to hydrochloric acid. How do we convert HCl gas to hydrochloric acid? Can you tell?
Reacting with water.
Okay. So how do we combine when
the
you
the inverted funnel arrangement?
Inverted funnel arrangement. Why can't we have direct tube? Why can't
a back section can occur, which will damage the apparatus.
Very, very good. So I will just show you. See, we are using this, isn't it? This is what you are using, right? Yes, this is inverted funnel. So why do we use inverted funnel? To increase, so that the surface area increases, to provide the large surface area for the gas. Okay, what is happening? If area is more, pressure will be less, isn't it? Pressure is physics, force upon area. So it's inversely proportional to area. So whenever area you are providing large surface area for the absorption of a gas, there will be less pressure and it will get dissolved. So to minimize back suction of water. So it is very important to complete. Now again, generally children write to avoid back suction or to minimize back suction. Back suction of what? You will write back suction of water.
Water.
Number two, to provide large surface area for the absorption of gas. Okay. So you have to write the complete sentence. So these are the two reasons why do we use the inverted funnel arrangement. So that's it. You just need to know. They will not ask you the procedure. They will only ask you what arrangement is used for converting hydrogen chloride gas to hydrochloric acid. You will say inverted funnel arrangement. Why do we use it? To minimize back suction of water and to provide large surface area for the absorption. Now, same question can be asked to you in another way. If I ask you, why is the direct absorption of HCl in water not possible or avoided? Why can't? Because it may cause back suction. Okay, there you will write it may cause, because if this, instead of this, if I use, for example, if I use only this tube, okay, I'm not using the inverted funnel. If I use this, what will happen? The water, it will quickly take in water. So what will happen? This water, the rate at which HCl dissolves in water is much higher than the rate at which HCl gas is being produced in the generating flask. So this water may go into the generating flask where we have concentrated H2SO4 mixing with NaCl. So it may break the flask. There may be an explosion. So to avoid all that, we use this inverted funnel arrangement, right? Now, coming back to the properties now. Dilute, I told you, dilute HCl or dilute hydrochloric acid behaves as a typical acid. For that reason, not HCl, any dilute acid, okay? Dilute sulfuric acid also behaves as a typical acid. Now, if I ask you, what is a typical acid? Can you tell me? What do you mean by a typical acid? What is a typical acid?
Which shows...
Yes.
Which shows all the properties of general acid.
For example, like whenever any dilute acid is added to an active metal, okay, or the metals which are above hydrogen, it will give you hydrogen gas. Salt and hydrogen gas is evolved. Whenever any dilute acid is added to any metal oxide or metal hydroxide, you will get salt in water. Whenever any dilute acid is added to metal carbonate or bicarbonate, you will get salt, water, and carbon dioxide, right? So these are the properties of typical acid. Whenever any dilute acid is added to any sulfite, metal sulfite or metal bisulfite, it will give you salt, water, and sulfur dioxide. Now, chemical properties are very, very important. They can see directly, they can ask you write the balanced chemical equation. Other than that, they can ask you state observations. Observations in chemistry is very, very important. Observation is what we see, what we hear, and what we smell. Because most of the time, children make mistake in this. And second thing in chemical property is they can ask you to distinguish between dilute HCl or dilute concentrated HCl with the help of a chemical test. So all these chemical tests involve observations. So first is whenever any dilute acid added to an active metal. Now, if you see here, magnesium with HCl, it is giving you magnesium chloride and hydrogen. Now, what will be the observation for hydrogen here? If I ask you, what is the observation for hydrogen? It's a colorless, odorless gas which burns with a pop sound. That's the observation. If I say hydrochloric acid in dilute form, what property, if this equation is given to you, NH3 plus HCl gives you NH4Cl, or Fe plus HCl gives you FeCl2 and hydrogen. State the property of HCl in the above equation. So you will say acidic property. Now, action of metallic oxides and hydroxides. Whenever hydroxide or any metal oxide combines with an acid, you will get salt in water. Now, this is the only equation where the observation for water is accepted. Otherwise, if you ask these equations, observation for water is not accepted. Here, you have to give observation
Carbon
for
dioxide.
carbon dioxide. And what is the observation for carbon dioxide?
A colorless, odorless gas which turns lime water milky but has no effect on potassium dichromate and potassium permanganate.
Very, very acidified. Acidified word is very, very important. That's the key word.
Oh.
So you will say a colorless, odorless gas which turns lime water milky and has no effect on acidified potassium dichromate paper. Okay. Whereas SO2, it's a gas which turns acidified potassium dichromate paper from orange to green. Okay. So that's the test for SO2. So if I ask you, now give a chemical test to distinguish between Na2CO3 and Na2SO3, that is sodium carbonate and sodium sulfite. Now, whenever any such thing is asked to you, say I ask you Na2CO3 and Na2SO3. Now, what is common in these two salts? First of all, sodium is common, right? So I'm telling you the way you should look at it. Now, sodium is common. We cannot differentiate on the basis of sodium. Now, carbonate and sulfite, these are the two things which are different. So how do we differentiate? On the basis of this? We know carbonates give out carbon dioxide and sulfites give out sulfur dioxide. So what do? We say add dilute HCl to both. Now, for carbonate, you will write a gas is evolved which turns lime water milky and has no effect on acidified potassium dichromate paper. Whereas here you will say gas is evolved which turns lime water milky but changes or turns acidified potassium dichromate paper from orange to green. Now, similarly, if I ask you Na2S, now I have taken sulfide and carbonate. Okay. Same thing you can write. What will you write here for carbonate? Here it is giving a gas with a rotten egg smell. Or it turns, you will see a gas is evolved which turns moist lead acetate paper to silvery black. And here no such gas is evolved. Always you have to give test for one and no such gas is evolved. Okay. That's how we differentiate. Now, next is bisulfites also, whether it is a bicarbonate or bisulfite, your products will remain the same. Salt, water, depending on if it is a carbonate, you get carbon dioxide. If it is a sulfite, you get sulfur dioxide. And if it is sulfide, you get H2S gas. And what is the observation for H2S gas? It's a gas with a rotten egg smell. So if they ask you action of dilute hydrochloric acid on sodium sulfide, state one observation. You will say a gas with a rotten egg smell is evolved. But if they ask you, give a confirmatory test for H2S gas, then you have to add a reagent. You will say, either you can say when H2S is passed through lead nitrate solution, a black residue is formed, because PBS will be formed. PbNO3 twice plus H2S will give you PBS plus 2HNO3. So lead sulfide is black in color. Or you can say it turns moist lead acetate paper to silvery black. These are the two tests that are for H2S gas. Now, always remember one thing, that all metallic chlorides do not react with dilute acids. Metallic chlorides, that means if it is NaCl, CaCl2, these are metal chlorides. They do not react with dilute acids. They react with concentrated acid only. Similarly, metallic nitrates do not react with dilute acid except, now there are exceptions here. lead nitrate, silver nitrate, mercuric nitrate also, but we have in our scope lead nitrate and silver nitrate, which are also used for the test of dilute HCl. Now, what happens when dilute HCl is added to lead nitrate solution? This should be 2 here. Now, when lead nitrate solution is added to hydrochloric acid, we get white PPT. Now, lead chloride is a metal chloride which dissolves on heating. Remember, if they ask you a metal chloride which is insoluble in cold water but dissolves in hot water, that has to be lead chloride. Now, same question, if I ask you, differentiate between dilute HCl and dilute H2SO4 using lead nitrate solution. So how will you differentiate? Can someone tell me? If I say differentiate between dilute HCl and dilute H2SO4 using lead nitrate solution. So what will you do? When you add lead nitrate solution to dilute HCl, what do you get?
You get lead chloride, which is soluble in hot water, but not soluble in cold water.
Okay, so you will say white precipitate of lead chloride is formed, which dissolves on heating, correct? Because it is dissolving, right, in hot water. Whereas with dilute H2SO4, you get white precipitate of lead sulfate, which remains insoluble on heating. So your solubility is giving this observation. Remember, so if they ask you using lead nitrate, white PPT of lead chloride, which dissolves on heating, white precipitate of lead sulfate, which remains insoluble on heating. Okay? And then we come to the using silver nitrate solution. Now, this is your test for dilute.
Excuse me, ma'am.
Yes.
Ma'am, here in this reaction, the white PPTs of lead chloride, they will also dissolve on heating. They will dissolve in nitric acid.
No, it will not dissolve. No, unless it is heated, it will not dissolve. Okay?
Ma'am, on heating, it will dissolve in hot water also and in nitric acid also.
It will dissolve on, yes, it will dissolve only when you heat it. See, Betty, lead nitrate solution is taken. We are not taking a salt, it's a solution, it's a precipitation reaction. See, we have to understand that also. Precipitates are formed when two solutions are mixed, right? That's how we get a precipitate. So we know that all nitrates are soluble in water. So lead, if we are talking about lead salts, only lead nitrate is soluble. No other lead salt is soluble in water. Okay, lead chloride, lead carbonate, lead sulfate, all are insoluble in water. So when you take lead nitrate solution, say I have it in this test tube and we have another test tube which has dilute HCl. So I will add dilute HCl to lead nitrate. Okay, so when I add this, I will see white PPT. HNO3 is your byproduct that remains in this, but you see a white PPT here. Now what I'm going to do is, because it is a solution, water is already there. So now I'm going to heat it on a Bunsen burner. So when you heat, you will see this white PPT dissolving. That is why I said white precipitate formed or white precipitate of lead chloride formed dissolves on heating. Okay? Got it? Understood?
Yes, ma'am.
Yes. Now, when we are talking about silver nitrate solution is used to identify dilute HCl or chloride test. Now, why do we say it is the test for the anion, chloride ion also? Because whether you use HCl or you can also use NaCl over here. Even if you use NaCl in place of HCl, still you will get AgCl, isn't it? Only thing is now byproduct will be NaNO3. Yes or no? Correct? So if I'm using AgNO3 plus NaCl, still I'm getting curdy white precipitate of AgCl, right? So that means that it's not only the test for dilute HCl, it is the test for this chloride ion, okay? Chloride anion. Tests for anions are we have tests for anions in our scope in practical chemistry. Like in semester 1, we had identification of cations. Now this time we have for anions. So please remember HCl gas. If they ask you the test for HCl gas, we are giving the glass rod test. If they ask you test for dilute HCl, you can just close your eyes and write add silver nitrate solution. You get curdy white precipitate of AgCl. Now this curdy white precipitate dissolves in excess of ammonium hydroxide solution. Okay. So this is your test. If they ask you for chloride anion also, then you can just give this silver nitrate solution. So instead of NaCl, they can give you any other salt solution of chloride. Okay, they can give you magnesium chloride also here. So you will get AgCl. So please don't think that, oh, MgCl2, why have they given magnesium chloride? This we've not done. It's not in the scope. It's not about that. You just have to concentrate on the anion, that what is being formed, because this is a solution, this is a solution. When two solutions are mixed, you are getting a precipitate. And what precipitate are you getting? AgCl. So whether you are getting AgCl from HCl or NaCl or MgCl2, doesn't matter. AgCl is a curdy white precipitate. Got it? Now, next we have test for concentrated HCl. We don't have all these equations, but we have this one, test. So whenever they ask you test for concentrated HCl, we use manganese dioxide. Okay. So MnO2, whenever added to concentrated HCl, it gives you salt, water, and chlorine. Now this chlorine gas is a greenish yellow gas. And what is the test, confirmatory test for chlorine? What's the confirmatory test for chlorine? If I ask you, it's anyone knows the confirmatory test for chlorine gas?
Okay, is that litmus paper test?
No.
It is a strong bleaching agent.
No, it is a bleaching agent, but what's the confirmatory test? That's not, you can't say even
iodide paper.
Yes, very good. It turns moist starch iodide paper to blue-black.
Yes, and black color.
Yes, blue-black. See, it's written here. It turns moist, it should be moist starch iodide paper to blue-black. Okay. So these are the few oxidizing agents. Red lead is there. Red lead is Pb3O4 and potassium dichromate or potassium permanganate. So all these oxidizing agents, why are we saying oxidizing agents? Because HCl itself does not have oxygen. HCl does not have oxygen, right? So it cannot act as an oxidizing agent. What is an agent which provides? Okay, oxidizing agent, it has to provide oxygen, no? So HCl does not have oxygen. How will it provide oxygen? So what does it do? It can be oxidized by strong oxidizing agents. So it itself gets reduced. So when it combines with MnO2, it gets reduced to chlorine. So H is removed. Okay. So that's the reason chlorine gas is formed. Now we have aqua regia. Again, aqua regia is not in your scope, but you need to know the composition, only composition, like what is it made up of? It is made up of concentrated nitric acid and concentrated HCl in the ratio of 1:3. That's it. Rest, you don't have aqua regia in your scope. Okay. So with this, we come to the end of this lesson, HCl, and we'll move to the second lesson, nitric acid. Okay.
Excuse me, ma'am.
Yes.
Ma'am, uses of HCl is in scope or not?
No. No uses are there in the scope. Okay. So we don't have uses.
Yes, thank you, ma'am.
In the scope. So let's go to nitric acid now. And I'll just share the screen with you.
Excuse me, ma'am.
Yes.
Ma'am, do we have the physical properties of HCl?
No physical property. Whatever I have done with you, we have only that much. And I request you children, let's follow the scope. It's always better, whatever we have in the scope, let's do it 3, 4 times, 5 times, rather than doing something which is not in the scope. Okay, we can do for general knowledge, we can do things later on, but as of now we will strictly we'll stick to the ICSE scope, what's given, right? You must be having that blue book. So in HCl, basically we have only lab preparation of HCl. We have conversion of HCl gas to hydrochloric acid by inverted funnel arrangement. We have fountain experiment. We have chemical properties. Physical properties are not there in the scope. And we, in chemical properties, whatever properties I have shared with you, we have only that much.
We don't have physical properties for any acid, ma?
No, we don't have physical property for any acid. Okay. So to be, okay, now nitric acid. When we talk about nitric acid, again, it is also known as aqua fortis, which means strong water. Just now, as they see, I told you in aqua regia, we are using concentrated nitric acid, a ratio of 1:3 with the concentrated HCl. So why do we call it strong water? Because it reacts with nearly all metals. It can even dissolve silver, and which is not dissolved in other acids. So nitric acid, basically, again, in nitric acid, we have only lab preparation and manufacture. Manufacture of nitric acid, Oswald process is there in our scope. So we will be doing lab preparation and manufacture of nitric acid, okay? So first thing, as I told you, whenever we speak about lab preparation, we are talking about reactants, name of the reactants. We will be talking about collection of the acid. We will be talking about the precautions that we have to maintain, and the test also, identification, which is very, very important. Now, lab preparation, it's the same. Instead of chloride, I'm taking nitrate, similar to HCl. So that's the reason I took these two lessons together, HCl and HNO3, so that you can relate with it. Now, for the common name for sodium nitrate is chili saltpetre, and potassium nitrate is nitre, N-I-T-R-E. So whenever sodium nitrate combines with concentrated, now again, concentrated H2SO4 is used in the lab preparation of nitric acid because it's a non-volatile acid. And why HCl is not used? Because being highly volatile in nature, it may volatilize along with nitric acid vapors. So the reason is same as we spoke about when we said that nitric acid is not used for HCl. Same reason we will give why HCl is not used for nitric, right? Temperature has to be kept less than 200 degrees centigrade. Now here, because nitric acid vapors are highly corrosive in nature, it's a highly reactive gas, it's a highly volatile gas actually. Nitric acid is very volatile acid. So here it may, all the apparatus that we are using is made up of glass. Even the stopper is made up of glass. Everything is made up of glass. We are not using any wooden cork. No rubber is used. Why? Because nitric acid, being highly corrosive, may attack rubber and cork. So that's the reason we use all glass apparatus. Now, once we prepare nitric acid, very common question that has been asked many times in board exams is that commercial nitric acid is yellow in color. Pure nitric acid is colorless. So what is the reason for this commercial nitric acid being yellow? That is due to the
presence of NO2.
Yes, dissolution. Now don't say decomposition, because decomposition will happen with the sunlight also. What is giving yellow color is because NO2 is dissolving in the acid. So you have to use this word. This word is very important. Due to the dissolution of reddish brown colored nitrogen dioxide gas in the acid. So this is giving yellow color to the nitric acid. Okay. So now this yellow color can be removed also. How can we remove the yellow color of nitric acid? By adding excess of water. If you pass it through excess of water, it can be removed. Or even by passing it through dry air, it can be removed. Though this reason may not be asked to you because it's not there, but you should know. This is important because it is in the lab preparation of nitric acid. Now, how do we collect the nitric acid? If you see the diagram, we collect nitric acid vapors are condensed to liquid by chilling the receiver under the running water. So the receiver is kept under running water. So that's how we collect nitric acid. I would like you to see this. Just give me 1 second. I have another PPT for you, which will give you a fair idea about it. Yes. Can you see this? All
Yes,
of you?
ma'am.
Yes. So if you see this, see the vapors, nitric acid vapors, they are collected in this receiver by chilling it under the cold running water. So that this is the way that we can collect nitric acid. Okay. The temperature, it has to be kept less than 200. Why? Because if the temperature goes above 200, then a thick crest of sodium sulfate is formed, which is difficult to remove. So equation will be less than, whenever they ask you lab preparation, it has to be less than 200 degrees centigrade. Okay. All glass apparatus has to be used. That's very, very important, because reason is because nitric acid vapors being highly corrosive may attack rubber and cork. Okay. So an identification. Now, whenever we speak about the identification of nitric acid, so that means we have to give the test for nitric acid. Okay. The test has to be given. So what do we do? All of you can see the screen because I've changed it.
Yes, ma'am.
Okay, thank you. So here the temperature, again, we'll say the temperature should not exceed 200 because at higher temperature, a thick crest of sodium sulfate is formed, which sticks to the wall and is difficult to remove. Now, when I was talking about the test is always when we are adding something to it. So if we have nitric acid on decomposition, I have told you, it gives you a reddish brown gas. Isn't it? HNO3 on heating also, it gives you, NO2 is a reddish brown gas. Okay. So whether it is sunlight or it is heat, it will give you a reddish brown gas. Now, for this equation, if I ask you the observation, since two gases are evolved here, nitrogen dioxide and oxygen, they may also ask you, name a colorless gas evolved when nitric acid is decomposed or decomposition of nitric acid. Colorless gas evolved will be oxygen gas. But if they ask you name a colored gas evolved, then it has to be nitrogen dioxide. Color of nitrogen dioxide is reddish brown. Okay. So whenever copper, say copper combines with nitric acid, if we are using copper with HNO3 concentrated, it gives you copper nitrate. Whenever concentrated nitric acid is there, you will get NO2 and water, always. And this NO2 is a reddish brown gas. Remember, wherever NO2 gas comes out, it is evolved, it will give you a reddish brown gas. You have to be rest assured. Okay. This has to be NaNO3. I think there is some typing mistake. NaNO3 plus H2SO4 greater than 200 gives you Na2SO4 and HNO3. This equation will be written only if they ask you, write a balanced chemical equation when concentrated sulfuric acid is added to sodium nitrate at temperature above 200 degrees centigrade. Otherwise, you will not write. For lab preparation, you have to make sure that you write less than 200 degrees centigrade. Okay. Now, whenever we are talking about manufacture is all about the large scale preparation. Okay. So large scale preparation, they may ask you, give all steps for the large scale preparation of nitric acid. or manufacture of nitric acid, or industrial process also. We can also call it an industrial process. Now, always in the manufacture, we give name to the process. What is the name given? Oswald process. Okay. Now, in Oswald process, we have 3 steps. Number 1, it is the catalytic oxidation of ammonia. Now, here, if you see in bracket, it's written 1:10. Catalytic oxidation means a catalyst, because ammonia is a good reducing agent. Remember, ammonia is a good reducing agent. It undergoes oxidation. We know reducing agents undergo oxidation and oxidizing agents undergo reduction. So ideally, when ammonia burns in air, it gives you nitrogen and water. Now, catalytic oxidation forces, this platinum forces oxygen to combine with ammonia, okay, this nitrogen. So that's the reason in catalytic oxidation, we get nitric oxide at 800 degrees centigrade. Now, this is your exothermic reaction. Plus heat is very, very important, because even when the heat is removed, the burner is removed, the platinum gives the reddish glow. That's your observation for this. Okay. Equation has to be, all equations need to be balanced. Now, this nitric oxide further gets oxidized. Now, when it further gets oxidized, it happens in the oxidation tower or oxidation chamber. If they ask you, write the balanced chemical equation, a reaction taking place in the oxidation tower of the Oswald process, then you have to give this equation, where nitric oxide, now NO is called nitric oxide. You cannot call it nitrogen oxide. That's wrong. Naming has to be correct. It is called nitrogen monoxide or nitric oxide. So when this nitric oxide combines with oxygen, you get nitrogen dioxide. It's a reddish brown gas. And then further, in the 3rd step, you have the absorption tower. Wherever the word absorption comes, children, always remember, we use water. So when water is added to oxygen and NO2, you get nitric acid. Now, since oxygen is used in all the 3 chambers, so that's why the ratio of air is more, 1:10. Why do we take oxygen? Why do we take 10 volumes of air is taken in this Oswald process? Because it is required in all these 3 chambers. So this is how we prepare HNO3 in the industry. That's the large scale preparation. Okay. So next we go to the, this is what is there. Higher ratio is used because it is chemical properties. Now let's go to the chemical properties. Now in chemical properties, we have thermal decomposition first. Whenever anything is decomposed, what do we get? We get water, nitrogen dioxide, and oxygen. This we've done. I told you, even with the help of sunlight or with the help of heat, you will get NO2. And dilute will give you nitric oxide. Okay. Now, dilute nitric acid. It's very, very important. Dilute nitric acid also behaves as an oxidizing agent. Why? What is the reason? Can you tell me? Dilute nitric acid. We say dilute nitric acid is also behaves as an oxidizing agent. It does not, when it combines with active metals, it does not give hydrogen gas. Why does it not give hydrogen gas? Can you tell me?
Because it's a powerful oxidizing agent which oxidizes the hydrogen to water.
Yes, which oxidizes hydrogen to water, because it's a powerful oxidizing agent which gives out nascent oxygen. Now, this nascent oxygen will oxidize hydrogen to water. So that's the reason it will not give out hydrogen. So, but we have exceptions. There are 2 metals, magnesium and manganese, with very dilute nitric acid. That means only 1% nitric acid is used. 99% is water. So very dilute nitric acid, with magnesium will give you magnesium nitrate and hydrogen. And very dilute, that means 1%, we have to write there 1% below dilute nitric acid. With manganese gives you manganese nitrate plus hydrogen. And this equation can also be used to show that nitric acid contains hydrogen. Okay. Now, acidic property, whenever we speak about acidic property, I have told you that acids behave as a typical acid only in the dilute form. Now, nitric acid is a strong monobasic. What is the meaning of monobasic acid now? When we speak about monobasic acid, we talk about the number of hydronium ions produced on ionization per molecule of the acid. It's very important that for one molecule of nitric acid, how many hydronium ions are produced? So if one hydronium ion is produced on ionization of one nitric acid or one molecule of nitric acid, that means it's a monobasic and it will make only one type of salt. Okay, so that is why we call it monobasic. You can stop me, children, anytime, wherever you feel that if you feel I'm going fast or you need to ask me something again, please feel free. Now, dilute nitric acid, this is the equation that I just mentioned to you, very dilute. You have to mention in bracket below nitric acid, which will give you hydrogen gas. Action with, now if I ask you, write a balanced chemical equation for the following. Dilute or give two balanced equations to show dilute nitric acid as a typical acid. So you can show with alkali, you can say with the NaOH or with bases, it is giving salt and water. So whenever acid is added to a base, it gives you salt and water. That's the typical nature of an acid, that you take any metallic oxide or metallic hydroxide, you add acid to it, it will give you salt and water, which is a neutralization reaction. Or you take any metal carbonate or bicarbonate, you add dilute acid to it, you will get salt, water, and carbon dioxide. So these are the few, you can say, the observations are very, very important. Few equations for the chemical properties of an acid. Now, say I've written here observation, a colorless, odorless gas is evolved which turns lime water milky and shows no effect on acidified. Acidified is the key word. You have to use it. And for metallic sulfides and metallic or hydrogen sulfides, hydrogen sulfide means bisulfite. So your reaction remains the same. When dilute acid is added to any metal sulfide, you get salt, water, sulfur dioxide.
Excuse me, ma'am.
Yes.
Ma'am, which acid resistance helps in dissolving NO2 uniformly in water?
NO2?
Uniformly in water.
NO2 itself is highly soluble in water.
Okay, ma'am.
Okay. So, yes. Now, next is metal sulfides. So if I have metal sulfide, so when metal sulfide is added to nitric acid in dilute form, it will give you H2S gas, which has a rotten egg. See, if they ask you in chemical properties, action of dilute nitric acid on zinc sulfide or ferrous sulfide or sodium sulfide, you can just write a gas is evolved, which gives or you can say a gas with a rotten egg smell is evolved. Only that much is required. But if they ask you confirmatory test, see, again and again, I'm telling you, confirmatory means you have to add a reagent. You have to talk about lead nitrate solution or moist lead acetate paper to silvery black. Okay. Now, these are the properties for dilute. Now, oxidizing property. Oxidizing, we said that dilute acid also behaves as an oxidizing agent, and concentrated, it always concentrated behaves because it can provide oxygen. So the first one, nitric acid with we have only 2 nonmetals in our scope and 1 metal in our scope. That's it. So whenever nitric acid combines with a nonmetal, now here nitric acid is in concentrated form. Remember, in concentrated form, it's highly volatile in nature. when it combines with this sulfur mineral, so it will give you the acid of that mineral, sulfuric acid. And NO2 and water, it has to come out whenever concentrated nitric acid combines. Okay, wherever you are using HNO3 in concentrated form, observation has to be a reddish brown gas is evolved, because NO2 is always evolved. Now with carbon also it will form acid. Carbonic acid is formed, but carbonic acid is the most unstable acid. It quickly breaks into water and carbon dioxide. So that's the reason NO2 water as it is, and this carbonic acid H2CO3 breaks into CO2 and water. So that's the reason here we have CO2 and water. And that's the reason here also, when we add nitric acid to any metal carbonate, we get water and carbon dioxide, because carbonic acid can never be formed. It's the most unstable acid. It breaks into water and CO2. Now next will be reaction with metal. Now with the dilute, we get nitric oxide, but with the concentrated, we get a reddish brown gas. So it's very, very important. NO is a neutral gas, which on oxidation will give you a reddish brown gas. So here you can say a blue solution is formed. Copper is a pink metal, which changes into a blue solution. And then we are talking about the aqua regia. Aqua regia, I've already told you, we don't have it in scope, but only composition you need to know, that it consists of, it is made up of concentrated nitric acid and concentrated HCl in the ratio of 1:3. Effect of heat, you need to know. This is oxygen. Okay, so this is oxygen, O2. So first two nitrates, KNO3 and NaNO3. Here it has to be, we can take sodium nitrate. Okay, so we have NaNO3 on heating gives you nitrite, NaNO2 plus oxygen. So we first two will give you nitrite and oxygen. So only oxygen gas will be evolved. If you are asked, state the observation or name the gas evolved. Thermal decomposition of potassium nitrate, you will say oxygen gas is evolved. Or observation is asked, you will say a colorless, odorless gas is evolved, which rekindles a glowing splinter. Now, from calcium to copper, if we go calcium, magnesium, zinc, lead, copper, they all will give you their respective metal oxides and two gases, NO2 and O2. NO2 is a reddish brown gas and O2 is a colorless gas. It's a neutral gas. Now, again, if they ask you, name a neutral gas evolved when lead nitrate crystals are heated in a dry glass test tube, you will say oxygen gas. Name a colored gas evolved when lead nitrate crystals are heated in a dry glass test tube. You will say nitrogen dioxide gas, so which is reddish brown in color. So terminology is very important. The way questions are asked, you have to understand each and every question and then give the answer. Equations remain the same. Now say this equation, these equations, the ones I have written here, you can be asked write the balanced chemical equation. You can be asked state your observation. You can be asked name the color of the residue formed. Now calcium nitrate, calcium oxide is white in color. Zinc nitrate, zinc oxide is yellow when hot, white when cold. Lead nitrate will give you PbO, which is buff yellow in color. Copper nitrate, if we are taking copper oxide, is black in color. So the residues, colors are very, very important, because observation is always for the colors of the residues or precipitates and for the gases. Okay, so this is important. And the last one, because silver and mercury are least reactive, they come at the bottom, isn't it, in the reactivity series, above gold and platinum, of course. So they will, on decomposition, they give their respective metals. So if they ask you, name a metal nitrate which on decomposition gives its respective metal, you can say it's silver or it is mercury, right? So for children, the numbers are already given here on the screen, the phone numbers. If anyone is interested, you may just call up to these numbers for further inquiries. If you are interested, please note the number. Second will be test for nitric acid. Test we have already discussed. I told you, whenever you add a metal to concentrated nitric acid, you will get a reddish brown gas. Okay. And if they ask you, name a nitrate which leaves no residue behind. So that will be ammonium nitrate, because on decomposition, it gives you laughing gas, which is nitrous oxide and water vapor. So it is ammonium nitrate is generally used in explosives, in RDX bombs, etc. So that's the only, we can say a nitrate which leaves no residue behind will be ammonium nitrate, and gas evolved will be nitrous oxide. Okay. So this is what we have in our nitric acid. So let's go to, now I would like you all to just solve this with me. We are going to do this questionnaire. I've made it for you. So whatever we have discussed right now, let's see. Yes. Anyone would like to ask any question? Okay, so let's start. Name the following. Can you tell me the answers now? You have to tell me. A gas which fumes in moisture.
HCl. Hydrogen chloride gas.
Yeah, HCl is wrong. Hydrogen chloride is correct. Now, what is the difference between the two? Because I asked you name the following. I didn't ask you the formula. So you have to say hydrogen chloride, not HCl. Okay. The acid which can produce sulfuric acid by oxidation of sulfur. Can you tell me?
Nitric acid.
Nitric acid.
Oh, sorry, it's just, okay, just a moment. Yeah. Can you see the screen?
Yes.
Yes.
Now, nitric acid is a wrong answer. What should be the right answer?
Hydrogen nitrate.
No, it has to be concentrated nitric acid. See, children, this is very important. If you don't write concentrated, then it is wrong, because only in the concentrated form it will produce sulfuric acid. Otherwise, no. So you have to mention that what is it, dilute or concentrated? So it has to be concentrated nitric acid. Okay. A gas which turns reddish brown when it reacts with oxygen?
Nitric oxide.
Nitric oxide.
Very good. Nitric oxide. A compound which is insoluble in cold water but soluble in hot water?
Lead chloride.
Lead chloride. Very good. A drying agent used in the lab preparation of hydrogen chloride?
Sulfuric acid.
Concentrated sulfuric acid.
Concentrated sulfuric acid.
Concentrated. Yes. You can't write sulfuric acid. It's wrong. Only in concentrated form it behaves as a drying agent. So concentrated sulfuric acid is the right answer. Okay, state one relevant observation for each of the following reactions. Action of dilute hydrochloric acid on iron 2 sulfide. Tell me. So what do I write?
A gas with a rotten egg smell is evolved.
Very good. A gas with the rotten egg smell is evolved. Very good. And if I would have asked you confirmatory test for the gas, then what would you
for
say?
this, can I write it reacts with acidified potassium dichromate paper with
No.
a solution which also has yellow particles?
No, because that is not accepted. See, ICSE is very choosy about observation. Now, please remember, for FES, for sulfide, so basically I have to give a test for this ion, no? Sulfide anion, right? Because H2S is evolved. So you have to say, either you will say a gas is evolved which turns moist lead acetate paper to silvery black. Okay, or a gas is evolved which turns lead nitrate solution to black. Only these two. Next, action of concentrated nitric acid on sulfur. Tell me.
A reddish brown gas is evolved.
Absolutely. See, wherever this word comes, concentrated nitric acid, you can just close your eyes and write a reddish brown gas is evolved. Because wherever concentrated nitric acid is there, there will be NO2. Okay. Thermal decomposition of nitric acid. Again.
Reddish
Reddish
brown.
brown gas.
A
Reddish brown.
Very good. A reddish
NO2
brown
is-
gas. Absolutely. Now, action of concentrated nitric acid on copper.
A reddish brown gas is evolved.
Absolutely. A reddish brown gas is evolved. See? So that's the way you have to, look at it. Oh my God, it's again going. Okay. Yeah. Now, lead nitrate solution is mixed with dilute hydrochloric acid and heated. So what will be the observation for this? Lead nitrate solution is mixed with dilute hydrochloric acid and heated. Can you tell me?
White PPTs of
White
lead
precipitate is
chloride are
formed, which
formed,
is insoluble in
dissolves on
cold water,
heating.
but dissolves when heated.
Yeah, so you can say white precipitate of lead chloride is formed, which dissolves on heating. Okay,
Oh.
which dissolve, and heated is said, no? So which dissolves on heating. Very good. Give reasons. All glass apparatus is used in the laboratory preparation of nitric acid.
Ma'am, because nitric acid is very corrosive, ma'am, and it
Yes.
Attacks
Strong
attacks
oxidizing agent.
all wood and
rubber and cork. Very good. So both things you have to mention. Nitric acid vapors are highly corrosive in nature. It attacks rubber and cork. So that's the reason all glass apparatus is used. Concentrated nitric acid appears yellow when it is left for a while in a glass bottle.
Ma'am, because of the
Because it
dissolved
react with
Because of
sunlight.
dissolution of NO2 in from the solid.
NO2 in it, ma'am.
No. What is the right answer?
And because it react with sunlight and produce NO2.
No.
Ma'am, because of the dissolved NO2 in it.
Yes. Dissolved NO2. See, that's the key word. Dissolved nitrogen dioxide or dissolution of the reddish brown gas in the acid. Okay. So that is important. Decomposition is taking place. It takes place in the sunlight also. But what is the reason they are asking? It appears yellow because of the dissolution. So what is giving yellow color actually? So reddish brown gas, NO2, which is dissolving in the acid, is giving the red, yellow color. Okay. So you have to write concentrated nitric acid appears yellow due to the dissolution of the reddish brown nitrogen dioxide gas in the acid. Okay, hydrochloric acid is formed from hydrogen chloride by inverted funnel arrangement.
Ma'am, because of the high solubility of HCl in water, ma'am.
It is formed by inverted funnel arrangement.
To prevent backflow and to
Yes.
increase the surface area for absorption of HCl
Absolutely.
into water.
To prevent
Backflow
backsuction
of water.
of water and to provide large
Surface area.
for the absorption of gas. Okay. Hydrogen chloride gas does not turn blue litmus to red.
It does not.
Because due to the absence of
hydronium
hydronium
ions.
ions.
Yes, due to the absence of hydronium ions. Very good. Now, see, sometimes, they give you some organic solvent. We know that covalent compounds, they do not dissolve in water and they dissolve in organic solvents. So some organic solvents are there which will, hydrogen chloride gas may dissolve in those, but still it will not turn blue litmus to red. Okay. So when we say hydrochloric acid is formed from HCl by inverted funnel, hydrogen chloride gas does not turn blue litmus to red. we will say due to the absence of hydronium ion. Similarly, when they say hydrogen chloride gas dissolved in toluene or dissolved in organic solvent does not turn blue litmus to red, you will say due to the absence of hydronium ion, because hydronium ions will be formed only on addition of water, nowhere else. Okay. Concentrated nitric acid is not used during the lab preparation of HCl.
Ma'am,
Due to
because
its
concentrated
volatic
nitric acid is
property.
very volatile. It's highly volatile.
Yes.
And it will mix with the HCl vapors, ma'am.
Yes, concentrated nitric acid being highly volatile in nature will volatilize along with HCl. Okay. Action of dilute nitric acid on calcium hydrogen sulfide. So can someone guide me what to write here? So if I ask you, what is the equation? What's the formula for calcium hydrogen sulfide?
CaHSO3 twice.
Okay. Ca. Am I right? Okay. And HNO3. So what do you get? What are the products formed?
CaNO3.
Ca.
CaNO3 twice
Yes. And
plus H2O
yes.
plus
Plus
no H2SO4 plus NO2. No, H2O plus SO2.
H2O plus SO2. See, it is a metal bisulfite. Metal sulfite or metal bisulfite will give you salt, water, and sulfur dioxide. Remember, okay? It will give you salt, water, and sulfur dioxide and balance the equation. What happens when copper combines with dilute HNO3? Tell me. Copper with cold and dilute HNO3.
CuNO3 whole 2.
Can someone tell me?
CuNO3 whole 2 plus H2O plus N2NO. Nitrogen
Very
dioxide not be just nitric
Yes.
oxide.
Yes. So you get copper nitrate plus water plus N. Okay. And of course, you will balance the equation. 4 and 2. Okay. Lab preparation of HCl, what do you write? What do you write for lab preparation of HCl?
2 NaCl plus H2SO4 under plus concentrated H2SO4 with temperature lower than 200 degrees Celsius gives NaHSO4.
So then why are you saying 2 NaCl?
Oh, okay. NaCl plus H2SO4 concentrated under 200 degrees Celsius, NaHSO4 plus
HCl.
plus HCl.
Correct. Now, sometimes, you know, whenever you are writing a paper, you forget what is the sign of greater or smaller than. So it's okay if you can write less than. So, or below 200. Okay. It's not necessary that you have to put this sign of less than. Action of dilute hydrochloric acid on iron. So what's the equation? Can you tell me? On iron.
HCl plus Fe
Fe
gives
plus
FeCl2
2HCl
plus
will give rise to
hydrogen.
plus H2.
FeCl2 plus
Fe
H2.
plus Fe plus
HCl.
Dilute to HCl.
HCl gives
HCl
FeCl2 plus
plus
H2.
Very good. Very good. Action of dilute nitric acid on ferric hydroxide. Okay. Tell me, ferric hydroxide. What do we write?
FeOH thrice.
FeOH thrice. Very good. Plus HNO3. What do we get?
FeNO3
3 whole
thrice.
twice.
Not
Thrice.
twice. Twice. Because see, the valency of iron is 3 here. Ferric. So if I'm taking ferric hydroxide, it has to be ferric nitrate. Salt and water, right? Yes or no?
Yes, ma'am.
Correct. Give all steps for the manufacture of nitric acid. Can you tell me what are the different steps? What is the first step for nitric acid? Manufacture.
First is catalytic oxidation of ammonia.
Very good. And the catalytic oxidation will make what? What is the condition?
A platinum catalyst.
Yes,
And
800.
800 degrees
800 degrees
Celsius temperature.
Celsius.
And what do you make?
Nitric oxide
Water
plus
with
water.
Plus water plus heat.
heat. Yes. And
4 NH3 5.
45, 46. Okay. Now, next will be
Oxidation chamber in which we convert nitric oxide to nitrogen dioxide.
very good.
50 degrees Celsius.
50 degree. And what will be the third one?
Absorption tower.
Absorption tower, in which NO2.
It's a room temperature, NO2 into
Correct.
plus water into nitric acid.
Very, very good. Okay. Now let's come to this very important question wherein you have to identify, okay? Compound X. You have to identify the anions here. Compound X, which on reacting with dilute hydrochloric acid, liberates a gas which turns lime water milky and turns acidified potassium dichromate solution from orange to green.
SO3 2 minus.
Sulfate.
Sulfide. Not
SO3 2 minus.
Very good. SO3 2 minus. Sulfide. So the anion present in compound X is sulfide. Bisulfite is also correct. Okay. Both are correct because both will give you salt water and sulfur dioxide. Okay. Identify the anion present in compound Y, which on reacting with sodium chloride solution gives a white PPT, which is insoluble in mineral acid, but soluble in excess of ammoniacal solution. What is the compound? When it reacts with sodium chloride, it gives you white PPT, insoluble in mineral acid, but soluble in excess of ammonia.
NO3 minus.
Very good. NO3. Silver nitrate solution. Ag. See, this is the equation. AgNO3 plus NaCl gives you AgCl precipitate and NaNO3. Okay. Okay, identify the anion present in compound Z on reacting with dilute HCl liberates a gas which turns moist lead acetate paper to silvery black.
S2 minus.
Very good. Sulfide. Because when sulfides, metal sulfide combines, any metal sulfide, you can take sodium sulfide with HCl, it will give you salt and H2S gas. Okay. So this gas liberates a gas which turns moist lead acetate paper to silvery. So H2S gas will be liberated only when we have sulfide anion. Okay. Okay. Name the gas evolved. Tell me. Thermal decomposition of niter.
Nitrogen dioxide.
Niter. What is niter?
Niter is potassium nitrate.
NO3. Yes. So thermal decomposition of niter will give you what? Nitrite and oxygen.
Nitrite and
So name the gas evolved. So gas evolved
Oxygen.
is oxygen gas. Dilute hydrochloric acid is added to copper hydrogen sulfide. Name the gas evolved. Copper hydrogen sulfide.
sulfur dioxide.
Sulfur dioxide. Ma'am.
Sulfur dioxide. Very good. Any equation asked to you when dilute acid is added to any metal sulfide or metal hydrogen sulfide or bisulfide, you get SO2. Concentrated hydrochloric acid added to manganese 4 oxide.
Oxygen.
Chlorine gas.
Oxygen.
Chlorine. MnO2 with concentrated HCl, salt, water, and chlorine. Okay, a greenish yellow gas. Chlorine gas is evolved. Concentrated whenever HCl is asked, it is always chlorine gas. Dilute HCl is added to magnesium carbonate.
Carbon dioxide.
Carbon
Carbon
dioxide.
dioxide.
Very good. Carbon dioxide. Dilute nitric acid is added to copper.
Nitric
Hydrogen.
oxide.
Nitric
What?
oxide.
Nitric
Nitric
oxide.
oxide.
Nitric oxide. Very, very good. Okay. Next is, give the name of this experiment.
Fountain experiment.
Fountain experiment.
What property does it demonstrate?
The high solubility of HCl
High
High solubility. State
and the acidic property.
State the color change. If there is methyl orange in the trough,
pink.
Colorless, ma'am.
pink.
Sorry.
Color change.
Color.
Pink. Okay. Acids will change, will turn methyl orange to pink. Okay. HCl gas is prepared in the laboratory. Answer the following questions based on the preparation. Name the reactants.
Ma'am, NaCl and sulfuric acid. Concentrated.
Sodium chloride. Say sodium. Name, bete. When
Okay,
name is
ma'am.
asked, we will stick to the name. Okay. Sodium chloride and concentrated sulfuric acid. Correct. Give balanced chemical equation for the reaction with suitable conditions. So what do
Ma'am,
we write?
NaCl plus H2SO4 below 200 degrees Celsius gives NaHSO4 plus HCl.
Very, very good. So NaCl plus H2SO4, concentrated is mandatory below H2SO4 and less than 200 is mandatory, and NaHSO4 plus HCl. How is the gas collected?
Upward displacement
of
of air.
Upward. And if I would have asked you, give reason or justify,
Because
Because
air is
HCl
lighter
heavier than
compared
air.
to
it
HCl.
is heavier than air. So it is collected by upward displacement of air because it is heavier than air. Name the drying agent not used for drying the gas.
Calcium oxide.
Calcium oxide.
Yes. And what is the reason?
Because it's
reacts with-
alkaline and when it reacts with an acid,
Alkanates
it forms
reacts
water
with
and
it.
salt.
Yes, because it is being basic in nature, it may react with HCl. Okay. So we are done with this. Now, if you have any doubt in these two lessons, you feel anything that you've not understood.
Ma'am, in this nitric acid chapter, we don't have that brown ring test.
Brown ring test is not there. Only thing is, if in case they ask you, you just need to know this, that it is used to detect the nitrate radical. Okay, I will just show you. So I'll just show you this. Just give me 1 second. Yeah.
And don't we have that reaction, some sawdust?
No, we don't have that. All that is not there.
This chlorine reaction, buff yellow, then forms nitrogen trichloride, all that is not there.
No, that's in ammonia. That's in ammonia. I think
Okay.
you're getting confused. Can you see the screen?
Yes, ma'am.
Yes. So you just need that you were asking, all this we had earlier. So basically, you just need to know this, okay? That it is brown ring test is only for the detection of nitrate radical. If they ask you, they can only ask you this, the detection of which radical, which anion for the
The
nitrate.
entire process, what all the
So
reactants, how do you add it, all that is not there.
The procedure equation is not there. So basically, what we do when we take freshly prepared ferrous sulfate solution. Why do we take this freshly prepared ferrous sulfate solution? Because if it is kept for a while, it gets oxidized to ferric sulfate, and then you will not get the brown ring. So we take freshly prepared ferrous sulfate solution, and we just add dilute nitric acid to it, few drops, and along the sides of the test tube we add sulfuric acid, 1 or 2 drops of concentrated, and we'll see a brown ring formed, okay, at the junction. So basically they can ask you maximum, if there is a question, that it is brown ring test is used for the detection of nitrate radical. That's it, okay? And this this is called nitrosoferrous sulfate. The brown ring is FeSO4.NO that you can see. It is the name of the compound is nitrosoferrous sulfate. Okay. So all this we have done, heating, okay, of this. These are the oxidizing agents we've done already. Physical properties are not there for you. So that is why I did not open this slide for you. Okay. So we have only this much. Anything else? Ask. Any doubt that you feel? No?
Uses of nitric acid is in scope.
It's not there.
Passivity.
Passivity is also not there. Okay.
Test for nitric acid and nitrates.
Test is there, of course. We did no copper. You add copper
Yes,
to nitric acid, it will give you a reddish brown gas, concentrated HNO3. It's there. Test is there. So basically, I'll tell you once again, in nitric acid, you have lab preparation of nitric acid. You have manufacture of nitric acid, Oswald process. And you don't have physical properties. You have chemical properties, wherein you have, in chemical properties, you have dilute nitric acid behaving as an oxidizing agent and concentrated behaving as an oxidizing agent. In this also, you have only 3 equations. 2 non-metals, sulfur and carbon, and 1 metal, which is copper. Okay, only this much. And dilute HNO3 with metallic hydroxide, metallic oxide, giving you salt and water, and carbonates giving you salt, water, carbon dioxide. That we've already done, typical acid. And then the test for nitric acid. That's it.
Zinc and iron.
Iron not there, no? Zinc also. Only copper is there for you. Though it will behave in the same way with zinc also. So if I am taking zinc with if I take this, say for example, I take zinc with HNO3 concentrated. So same thing, I get zinc nitrate plus NO2 plus H2O and balance the equation. Same as copper. And both have valency too. So balancing will also remain the same. So if you are taking zinc with the HNO3, which is cold and dilute, so again, my products would be zinc nitrate plus NO plus H2O. Okay. So it won't change. Right?
Excuse me, ma'am.
Apurva.
Excuse me, ma'am.
Yes.
How we deal with the chemical reaction? Is anything is mugging up or anything else?
No need to mug up. See, whenever we are writing, see, you need to know this. Like you write metal. Whenever metal react with dilute acid, you say we get salt and hydrogen, isn't it?
Yes.
So I can take any metal. Say I have zinc. Okay, I take. So zinc is above hydrogen in the activity series. So this hydrogen is displaced. So hydrogen is a diatomic gas. So it exists as H2. So zinc will come and take the place. Displacement, no? So Z
Yes.
and Cl2, because zinc is 2 plus, Cl is 1 minus. So I know it is formed. So there is no mugging up in this. If you have any carbonate, say I have this carbonate, I have HCl, dilute HCl. I know when dilute acid is added to any carbonate, I get salt, water, and carbon dioxide. What is salt made up of? It is made up of a basic radical and an acidic
Acid radical.
Okay. From acid, I take the acid radical. And from this salt, I pick the basic radical, Na. I make a salt. So the salt is NaCl. Salt, water, carbon dioxide, because it's a carbonate. So I write this equation. Isn't it? So same way.
Yes, ma'am.
Yeah. So if you take sulfide, I will get sulfur dioxide. So there is nothing as in, you can't learn equations. It's impossible. There are so many. You'll get confused or you will go blank. You have to understand this way. And no equation is, difficult to understand. You just
Yes,
need
ma'am.
to know what is formed. So if I have, say, lead nitrate solution, for example, if you have lead nitrate solution, okay, and HCl, I know these are 2 solutions. It's a double decomposition reaction. 2 solutions when mixed give a precipitate. So exchange the radicals. If you pick up anions, so this anion goes here and the nitrate chlorine goes there and nitrate comes here. So lead is 2 plus, so PbCl2 and HNO3 and balance the equation, isn't it?
Yes, ma'am.
Yeah. Anything else?
Ma'am, this test paper which we discussed right now, will it be available in that study material section?
It should be there.
Okay.
Okay. You'll get it.
The PDF of the ma'am, that PDF is also in the study material.
The PDF that I've just
Yes, ma'am. Yes, ma'am.
Yeah, it should be there. It has been and just you can always float it to your friends also. So the numbers were there, and you may just subscribe, call on these numbers, and you can get more question papers and the study material, whatever is required. So we'll be doing everything slowly and gradually. I'll be sharing more papers with you, right? So anything else?
Ma'am, I have a question.
Please ask.
Ma'am, how can we prove that HCl contains hydrogen and chlorine other than the method of electrolysis?
Other than the method of electrolysis,
Yes, ma'am.
hydrogen can be proved when you are using any active metal with HCl, isn't it? Hydrogen gas is coming out.
Yes.
Yes or no? Though there is a thermal dissociation also. Thermal dissociation can take place at temperature greater than 500 degrees centigrade. You will get hydrogen and chlorine. Okay?
Okay,
And the
ma'am.
second is, you can just, for hydrogen, you can use dilute acid. And for chlorine, you can use concentrated acid. You will get chlorine gas. Okay?
Okay, ma'am. Thank you.
Yes. Anything else? No? So we can call it off?
Yeah, ma'am.
All good?
Yes, ma'am.
Okay. I hope you understood. Yeah?
Yes, ma'am.
Yes, ma'am.
Okay. Thank you, children.
Thank you, ma'am.
Thank you so much, ma'am. Bye,
Thank
ma'am.
you.
Thank you so
Good
much,
night.
ma'am.
Bye-bye.
Good night, ma'am.
Good night. Good night. Take care. God bless.
Thank you, ma'am.
Bye-bye.